Welcome back, children, to the lesson force and pressure. In previous class, we discussed about what is force and what is pressure and what are the applications of this force and pressure. We discussed. Now, let us see the pressure. The pressure applied by the liquids. Pressure applied by liquids. Pressure applied by liquids. So here liquids can able to exert pressure. Liquids can show the pressure, right? How can you say that liquid can able to show the pressure, right? So I will start with a simple experiment, right? Now see here, for example, it is a tumbler. Tumbler is nothing but a vessel. It is a vessel. It is a bottle. Just imagine it is a bottle, and in this bottle, just fill the water. Fill the water up to here, right? And make a small hole at the end, like an outlet, right? Then what happens? Water leaks out of the hole. Now increase the water level. It is A. Now increase the water level. Guess what happens to the flow? Very good. The flow increases. The flow increases. When you increase the water, then flow increased. Now pour some more water in that bottle. Then what happens? Again the force increases. Again the force increases. Right. So what do you understand by this? What do you understood? So here when water is less, the weight of the water is less, so that it shown very less pressure. Whereas when you increase the water, then depth of the water increased or weight of the water increased. So when weight of the water increases, then automatically pressure increased. And finally when you add some more water on this, the depth of the water so much increased, so that pressure also increased a lot. It means the liquids can able to apply pressure. It shows the pressure on the walls of containers in which it filled, right? So where do it shows the pressure? It can able to show the pressure on two places of the containers. Number one, at the bottom of the vessel. It show pressure on the bottom of the vessel, and as well as it exert pressure at the sides of the vessel. Sir, how can you say that, right? So let us see with the examples. What I am saying here, the liquids can exert pressure at the bottom of the vessel and as well as sides of the vessel. So however the depth increases, for example, if you enter into the swimming pool, if it has low depth, then there is no much pressure. Whereas if you go into the deeper layer of the water increases, means the weight of water increases. As a result, I already told you, if weight increases, pressure also increases, so that the pressure will be increased when you go into the water level. That's why the diver, the water diver is going to carry a cylinder, oxygen cylinder. While diving, he carries the oxygen cylinder. Why? Because if we enter into the water layers, deeper layers, then water pressure increases. If we don't carry that, he is unable to breathe. His lungs are going to get collapsed. So that he is carrying a oxygen mask and oxygen cylinder, and he dives into the water. Right? So here let us see how do it show the pressure. Now water shows pressure on the walls. So take the water in a container, and simply you do one thing, make a outlet and cover it with a balloon, uninflated balloon means normal balloon रखना है यहाँ पे, right? Now when you pour water into this vessel, then what happens? When you pour water up to here, it inflates somewhat, and when you increase, then it inflates, and if you increase more and more, then it inflates like this. Means water exerting pressure on the container sides of the container. In the same manner, if you want to test whether it shows the pressure at the bottom or not, same again, tie the balloon here. When you increase the water, the balloon inflates and it becomes bigger like this. So here water can able to show the pressure, or it exerts the pressure on both the sides, at the bottom and as well as at the sides of the vessel. These two indicates that water can able to show the pressure. Actually, if the height of the water increases, then pressure increases. That's why the water tanks at our home, the water tanks are arranged at the roof. Why at the roof? Because due to gravitational force and as well as the water pressure, the water comes down easily. If you arrange at the ground level, you are able to get the water to the upstairs. So that's why we arrange the tankers at the roof only, right? And if you increase the height of the water, then definitely the pressure and force increases, right? So this is about example. If you don't get this, simply whenever the tank is full, your water tank is full, if you open the tap, then water comes with the pressure. What happens when water decreases? The water coming out of the tap also decreases, right? Very simple. So like this, liquids show pressure, and as well as gases also exert pressure, right? So let us see how do the gases show the pressure. Simply take a balloon and inflate means air funkna, right? So when you inflate the balloon, right, then balloon inflates, and after that tie the mouth of the balloon and try to press it. What happens? It pushes your hands back. When you are trying to press the balloon, your hands are moved away from the balloon. Why? Because the gas inside the balloon, it is pressing it shows the pressure on your hands, right? And as well as it always exert pressure on the balloon cover. If you inflate the cycle tire more and more, what happens? At a point it is going to burst out. Why? Because air exerting pressure, or otherwise simply take a injection syringe, and pull the piston back and keep your finger at the nozzle and try to push the air. Then what happens? The air tries to push your finger off of the nozzle, right? So here we come to know that air can able to apply pressure. The pressure applied by the air on a unit area is called atmospheric pressure. Atmospheric pressure. What is meant by atmospheric pressure? Here it is earth, and we know that earth is surrounded by atmosphere. In the atmosphere there is presence of air. The maximum atmosphere is made up of air, right? So here this air, it exerts pressure on the earth. It shows pressure on the earth. Whatever the pressure that shown by the air that is present in the atmosphere, that pressure is called as atmospheric pressure. So for example, on the earth, let me take a small part. It is a unit area, and if you take the column of air, here, the air molecules are more at the bottom and they become less when you go up. So here the pressure of the air is more in the beginning session, but when you go into the sky high and high, then the air pressure decreases. Air pressure decreases. Why? Because naturally availability of air is less. Availability of air is very less when you go up into the sky, right? So atmospheric pressure is more at the sea level. It is called sea level. Atmospheric pressure is more at the sea level and less in the height of the sea level, means mountain. At the mountain pressure is less and at the sea level pressure is high, right? At the atmospheric pressure at the sea level is 1 pascal, right? Atmospheric pressure is 1 pascal at the sea level. If you go into the hills, then air pressure decreases. Air pressure decreases. Here at your home, if you cook the rice in the pressure cooker, it takes 10 minutes or 15 minutes for cooking in the pressure cooker. If you want to cook the rice at the hill region, then you require more time because air pressure is less here. Air pressure is less, so that to cook the rice at the mountain level we require more time. It takes more time to get cooked, whereas at ground level, at the sea level, cooking of rice is very easy, right? So this is what called atmospheric pressure, that is showing on an unit area of the land. The pressure applied by the atmosphere onto the unit area of land is called as atmospheric pressure. Atmospheric pressure, right? So this is about pressure exerted by the gases and as well as liquids. We'll continue the lesson in further sessions. Thank you.